I'm going to talk today about Filecoin. I'm going to do this from the perspective of someone that has some basic knowledge of Filecoin, but is technical and wants a bit more technical background on the storage side of Filecoin. So Filecoin being a blockchain that does storage. These two things might seem strange together because it's actually a very functional blockchain that does more than Ethereum doing compute, for instance. It does storage of large amounts of data. So what I want to do is try and pull that apart and give you a clearer mental model of how this thing works so that you can approach it in a more constructive way. So to start off with, I'm going to look at just some Filecoin basics to explain what's going on with Filecoin, and we'll build on there. So Filecoin is a blockchain managed distributed storage system. So the important part of that is that the blockchain manages the storage. The blockchain doesn't own the storage. So this blockchain isn't just full of petabytes of data. Although the blockchain is big, it doesn't actually contain the storage. The accounting for the storage lives on the chain, but the storage doesn't live on the chain. And I'll explain more of that as we go on. The native Filecoin token is FIL, F-I-L, and there's a little symbol that's often used for it as well. Now, Filecoin miners are a little bit different to proof of work miners. Filecoin miners offer storage to a market, and that is how you mine Filecoin. Clients and miners negotiate deals one-to-one. So I, as a client, might find a miner and negotiate a deal to store my stuff. I also might make deals with 10 other miners for the same data just to get them redundancy. But it is a one-on-one negotiation. But we negotiate and finalize through the chain. So, well, not fully negotiate, but this is mediated through the chain in a way that is safe for all parties. Miners keep batched data static for predefined periods of time. So miners are responsible for collecting up data, packing it up, and then freezing it for periods of time. That's the basics of how Filecoin does storage, these batches, frozen periods of time. Miners have to continually prove that they still hold the data during that period. They are responsible for proving to the chain that they have still the data they had when they froze it up. Now it uses a proof system called proof of space-time. So this is different to proof of work that is found in classic blockchains. Proof of space-time is proof that you are offering the space of storage over a period of time. Now, the chain holds, as I said, holds miners accountable for proving they continue to hold this data. The proof is a zero-knowledge cryptographic algorithm. That is, the chain doesn't need to have the data to receive valid proof that the miner still has the data. So that might sound a little bit strange, but these proofs are clever enough that the miner could be the only computer in the world holding that data, and they could still be held responsible over the period of time they have it for proving that they still have it. So these are some very, very clever zero-knowledge proofs. If you're interested in that, I would recommend looking into it because these are fascinating bits of work. Miners receive tokens, FIL, from clients through negotiated deals, so they can earn just by offering storage. Obviously, you know, I have a lot of storage space, and I want to sell it to clients. I negotiate, and they pay me in native tokens. But they also receive rewards from the chain. So like in other blockchains, they receive rewards from keeping the blockchain executing. So this blockchain, it has a rate. It has to keep on executing and keep on adding new tips over time, and miners participate in that activity, and they do get rewards from that. And it can be quite profitable for some of the larger miners, just like in every other blockchain. So onto some storage basics. Let's look at how Filecoin does storage. Typically, miners are continually sealing new sectors. So sectors are defined as blocks of these units of either 32 gig or 64 gig at the moment. That may change into the future, but right now those are the sizes that miners could select from. So these are the batches that they are sealing. They are freezing over time, and typical miners are continually doing this, whether it's sealing completely new sectors or resealing old ones, or putting new sectors over old storage when they expire. They have a pre-specified lifetime, pre-specified by the miner within a range of 18 months to 6 months. Depending on miner preference, they can choose within this window, depending on various factors. And that obviously will impact the size of deals as well that you can have storage for. So this is not I want you to store my data for 100 years kind of thing. You would have to renew deals or make new deals to keep data alive for longer periods of time. But there are mechanisms for extending these things. I won't go into any of that today, though. Sealed sectors, so these frozen sectors, they contribute to miner power. Power increases the miner's chances of winning block rewards from the chain. And so this is how they earn tokens from the blockchain and not from deals. So the more sealed storage a miner has, the more power they have in the network and the more likely they are to win block rewards. So large miners are earning quite a few block rewards because they have a lot of sealed data. Now, what's in this sealed data? Well, these sectors, they may or may not contain data from clients in the form of paid deals. There's 3 types of data that you'll find in sectors at the moment, and there could be variations of this into the future, but right now, the 3 types are committed capacity, which I'll look at in a minute, but that's basically empty storage, unused storage, regular deals, and Filecoin Plus deals. So there's deal data and then there's no data. And there's no requirement for the mix of data types in sealed sectors. They contain bits of each of these things, and it all gets worked out in the end. Sealing creates a unique copy of the data in a sector. So this is part of the proof system. So when you seal, you create this unique copy that is then provable. And then the sealing process prepares it for that ongoing proof of space-time process where the chain will query the miner. Now, sectors containing no deal data, they're called committed capacity. Committed capacity, they contribute to the total network capacity without storing useful data, which might sound kind of bad, but they exist to remove the incentive to self-deal or faux deal, fake deal. If these things didn't exist, then you would find miners pretending to do deals. Oh, look, I've got a deal of these random bytes, and oh, isn't that nice? So there's no incentive for doing that. You can just store nothing, and you can still earn rewards. This is one of those things you can't get around, so it's just built into the system. But that's okay because that contributes to a total network capacity, which is real storage, and it signals to the network that there is real hardware ready to store data, even if those sectors are currently empty. So this is a moving thing. These sectors are constantly expiring and being renewed. So even though the capacity might look big and the number of deals might look a lot smaller than that, especially now in the early stages of Filecoin, the signal there is that storage is real. It is being proven. There's serious hardware behind it. This network is ready to store large amounts of capacity. So that's an important signal. Sectors that contain deal data are then generally called regular sectors. So committed capacity sectors are empty. Regular sectors have at least some deal data in them. Now, proving. So miners, as I said, have to continually prove they retain each of the sealed sectors as they were frozen. Miners must submit a proof of space-time, otherwise known as a post, at regular intervals during each day of a sector's lifetime. Management of the deadlines of these proof submissions, they're done as windows. So you have to submit within these windows, and those windows are managed on the chain, and that's where the term window post comes from that you may see if you've hovered around Filecoin at all. So this is a critical thing for miners. They have a window of time during regular intervals to post proofs that they still have that data that they sealed, and they posted the details for in the beginning. Miners are penalized if they can't prove or they miss consecutive proving deadlines. There is some grace built into the system where you can have small outages, you can have small network problems, there can be minor chain problems, but this system is heavily optimized for always available, always being able to prove. Sectors not proven over 14 consecutive days are terminated automatically, and the penalty is applied. I'll talk more about that later. Clients who have deals terminated in terminated sectors have a portion of their funds returned to them, so you don't lose out if a miner goes down. There's penalties all around, and you as a client, you get reimbursed for at least some of your loss. Collateral is an important concept for the incentive system. Miners lock up an amount of fill collateral when they seal sectors. So when they lock up one of these 32 gig or 64 gig sectors, they also have to pay. They pay an amount of fill, which is determined by the chain state at the time of sealing. That gets locked up with the sector. And additional collateral requirements may also be introduced as part of deal negotiations. So deals within sectors that have collateral the deals themselves may also have collateral requirements, and that collateral would be a client saying, look, this data is really important for me. If you're going to store it and I'm going to pay you this price for storage, I also want you to put up a bond to show me you're serious about it. When the sector expires without fault, collateral is returned. So it can cost the miner to get in, but they get that back. So they're locking it up to earn block rewards and deal rewards, and then they get that back as well. So if you think about it for a little while, the incentives that this serves, I'll go into the details later, but this is kind of important to making sure this is a reliable system. And yeah, I'll talk a bit more about incentives as we go on. Making deals. Deals are made in a live market, as I said, one-on-one. So a client contacts a miner directly, and this is roughly the process. There's lots of subtle points within this, and I may have a couple of things out of order, but this is the basics of how it's made. So a client requests deal conditions from miners. So you can do this one-on-one. You can do it in a batch. Like you could spawn out and request deal conditions from all the miners that are speaking, and that the deal conditions roughly come back as, this is the price I want per gigabyte per chain epoch, which is 30 seconds. The minimum deal size and the maximum deal size. There's a little bit more information than that, but that's roughly what they say. They say this is how much it's going to cost you for me to store your stuff, and these are the parameters of size. Then as a client, you propose, if that's acceptable, you propose a specific deal within those parameters. So here's my data size, and here's what I'm proposing. The miner then has to accept that deal, and there's various reasons and ways that miners can reject deals even if they are within their conditions. So miners can have filters of things that they don't want to accept. There's a lot of ways, a lot of reasons that miners may not want to store your data. After they've accepted, you transfer the data to the miner. The miner then includes that deal data that you've given them within a sector that they're committing, or either currently or they'll queue it up. And then once it's sealed, the deal confirmation is placed on the chain, pointing to the sector, and the sealing of the sector. The replica. The replica proof is placed on chain that is ready to set up for these window posts over the period of the time of the sector. So it gets a little bit murky in there. I'm not entirely clear on exactly what gets placed on the chain there, but basically this process is done in such a way to ensure that the funds transfer and the data transfer is solid, that you can't renege on a deal during critical parts of this, and you can't, a miner can't back out and a client can't back out once they get to certain points of this process. So it's very safe, and the important parts are mediated by the chain. Funds, so fill is used, the fill used for deals is mediated through the chain. As I said, when proposing a deal, the client must have fill provably locked up in the Filecoin market. So there's this space on the chain called the market. You have to have fill out of your wallet and into this market in order to make these deals. So it's like saying, here it is. If I want to make this deal, and you can look in the market and see that I have it ready to go. Upon the successful deal and the seal, the funds are then locked into escrow. So they're moved from the market availability for deals into an escrow where they're just completely locked up for the life of the deal. And then they're paid out over the lifetime of the deal to the miner. So the miner, it dribbles in over that time. So they get the reward as they're storing. And it's just sitting there in the chain waiting to go. Filecoin Plus is a variation of deals. So we have regular deals and we have Filecoin Plus deals. Now, Filecoin Plus is a social layer that sits above the chain. So, um, blockchains are essentially code-mediated um, social networks or computer networks. So the rules of the network are embedded in the code, and that defines exactly how we deal with each other. Filecoin Plus adds a social layer, a people layer above that, that connects into the chain. So how it works is these notaries or organizations defined by Filecoin Plus, they're selected by the Filecoin community. There's a process for nominating and selecting notaries. And they're distributed around the world. There's a geographic distribution rule about these things, and notaries are responsible for handing out what's called data cap to users. Data cap is like a quota that can be spent along with Phil to make Phil Plus deals. So when you're making a deal, you can say this is a Filecoin Plus deal. I have data cap available. I have some quota from a notary that I'm willing to make with this deal. The special thing about Filecoin Plus that on the chain is that Filecoin Plus deals contribute 10 times the miner power than regular deals or committed capacity. So committed capacity and regular deals in sectors commit the same amount of power. But if you have Filecoin Plus deals in your sectors, then they will contribute proportionately to the power of your miner. So if all of your sectors are full of Filecoin Plus, then you need 10 times fewer sectors to have the same amount of power as somebody who doesn't have any. Unfortunately, collateral requirements are also 10x, so it does cost a lot also to get these sectors sealed. But again, these are all incentives. Chain explorers, if you look around at miners on Filecoin chain explorers, you'll see things like raw power versus quality adjusted power. That discrepancy comes from Filecoin Plus deals. That the quality adjusted is adjusting for this 10x within the deals, and they can be fractional because it is proportionate. Filecoin Plus deals should be attractive to miners, so they may charge less to get them. They align the market towards storing real data. That's the intention of Filecoin Plus. It's a fairly new program. It's still rolling out. Notaries are still signing up. You can actually get a small amount of data cap free if you've got a long-standing GitHub account. I think it's like 8 gigs a month you can get. And there are a lot of miners that will actually charge you 0 Phil to store your stuff if it's a Filecoin Plus deal. It's that valuable to them at the moment. As the network goes on and the market matures, those the levels of pricing will change as it becomes much more competitive and interesting. But right now, you can actually get free storage if you've got Filecoin Plus data cap to spend. Deals can be performed offline as well. So you can do it through the normal flow where you're transferring information to a client, data to a client, or you can do it offline. And the way this works is you make a standard deal between client and miner, but then you ship the data, perhaps manually, perhaps you actually stick it in the post and ship it to the miner who loads it into a sector. And this is really good for large storage amount because it's often cheaper and faster to ship hard drives than transfer some of this data over the internet. When we're talking about petabytes, you're probably better off shipping hard drives. So you can make offline deals to do really large storage. That's a thing. It does happen, and the use cases for this will grow, I think. Failure modes. So there is such a thing as failure modes. This stuff can fail. A failure will incur penalties for miners, and those penalties are described as slashing. Failure to prove a sector results in a per day faulty sector penalty. So even if you miss a day, you still get a penalty. But these 14 consecutive days will result in a sector's termination, and that makes the unpaid escrow funds return to the client. And there's also an additional penalty imposed on the miner proportional to the rewards the miner would have earned. And so there's a lot to lose here for miners to have failures. The incentives align very strongly for reliable 100% online storage. So great hardware, connectivity, ops, the whole lot. So this system really aligns for solid storage, not just some guy with a dodgy modem and a hard drive to spare. This is about serious storage on very large scales. So it encourages long-term investment in the chain as well. So leaving Filecoin as a miner will cost either time to get out to have your sectors terminate naturally, or fill. You if you terminate early, then it's going to cost you in the collateral and the penalties. That's failure modes are very well accounted for, and they lead to very strong incentives for longevity and solid storage. So further reading, if you want to read more, head over to filecoin.io. There's a doc site there and a spec site there. The spec is very big. It's always being expanded because it is a complex system, but there's a lot of details in there about some of these workflows, about some of the penalties, some of the incentive systems. Very interesting to read. And that's about it. I haven't talked at all about retrieval. There's retrieval is a whole nother ball game. And I also haven't talked much about the relationship. I haven't talked at all about the relationship to IPFS, but it is in there that Filecoin grows out of IPFS technologies. They all underline this system, and there's a natural synergy between those two. But that maybe is for another video. So that's all for now. Thanks for watching.